Welcome to Functions and Classes for Finance 372. The best programmers are often lazy by nature because their laziness motivates them to automate their processes and find less repetitive solutions to their problems. Two key concepts that allow for clean, non-repetitive code are functions and classes. Functions allow a piece of code to run over and over again in different settings without copying and pasting it each time. Classes bring together functions and data and allow your code to be reusable for different settings. Using functions and classes may seem like extra work at first, but in the long run, they are a lazy programmer's best friend because they save time and vastly increase what you can achieve. Let's start by taking a look at functions. We've typically been starting these notebooks by loading some data. But what if you consistently want to load data at different places in your project and you don't want to have to copy and paste that code every single time? Well, in that case, we can write a function that does this for us. The syntax for this is we have to write def, which defines the function, and then we have to give it a name. So let's name this load data. Okay, and after the name and the open and close parentheses, we need to have this colon here because that tells Python the following code is part of the function. So within this function, let's load our normal yield curve data that we've looked at for a few videos now. As always, we read the CSV and we change the date column to a date time column. Okay, now inside of a function though, this code here will only run in the little world of the function. It does not create a df_yc variable we can use anywhere else. When you're done with your function, to get a variable out back into the real world where you can use it, you have to use something called a return. In this case, we'll return this data frame that we've loaded. Okay, so what this function does is when you tell Python to run the load data function, it loads this CSV into a data frame and then it returns that data frame to whoever called the function. All right, so notice when we run this function, what happens is nothing. The data doesn't actually load right now. There's nothing called df_yc for us to reference. To actually call this function, have it load the data and give us a data frame, we need to say df equals load data. By writing load data with these parentheses, we're calling that function. That function returns a data frame. We're going to store that return data frame into df. Okay, but even after I've run the function and executed it, Python still doesn't know what df_yc is. df_yc lives only in the little world of this function. We cannot access it outside of the function. If we want to get something out, we have to return it. We return it. We saved it in df. We can access df. All right, so let's say now we do something. We modify this df a little bit. Let's say we just grab all the rows that have a maturity of 1 and make that our new df. It's got only 900 rows now. If we want to go back to where we started and get the original data frame we loaded, we can always just do df equals load data. And now we're back to the full 6505 column. And now let's find another function that will compute for us the prices of a zero coupon bond as a function of the yields to maturity and the years to maturity. I'll name this ZC as in zero coupon bond price. And now, unlike with my load data example, now I don't want to just get data out of the function. I also want to put some data into the function. I want to tell it which yields to maturity to use, and how many years to maturity to use, and what the face value of that bond is. Let's name these variables YTM for yield to maturity, maturity, and face value. So anything in parentheses here, separated by commas, these are the names of the pieces of data or the parameters we're passing into this function. You always have to have the colon here. And I should note that when you're writing a function, Python will automatically indent the next line because anything in here will be inside the function. And when you're done with the function, you want to go back to normal code, you have to do Shift-Tab and go back to here. Here is outside the function. Okay, so Python is one of the few languages that decides whether you're still inside of a function or a class using the indentation. So the indentation is very important here. There's no parentheses or brackets that decides this. Okay, so now we're inside the function here. How do you compute this? Well, we all know the formula, so I'll just write it out. All right, so this function is simple. It just returns the face value discounted by the yields to maturity to the maturity power. Now, we run that cell, and our function is created. And we can use the function anytime we want. So let's do a zero coupon bond price with a 2% yield to maturity for 10 years and a face value of 100. And let's do the same thing for a 20-year, 5-year bond and 3%. All right, so we see we have our two different prices. Let's say we want to make this function a little bit easier to use by making it have a default value for the face value. Most of the time we're going to be wanting a face value of 1,000. And so instead of having to type 1,000 every time, it would be nice just to be able to do this and just leave that 1,000 off and have that be assumed by default. Okay, if I do that now, it's going to say it's missing one positional parameter face value. What I can do is I can go back to this function definition and give a default value right here in the definition of the function. So if I assign a value to one of these parameters inside the function definition, that will be the default. If I don't tell it a face value, it will assume I'm using 1,000. Now we can rerun that cell defining the function with a new default for face value. And if we run this again, we get back the correct answer. It's assuming in this second case that your face value is 1,000. Notice here that I can still override that face value. I can still pass in something else that's not 1,000. But if I don't pass anything, it will assume a 1,000 value. One problem with calling functions this way is you may forget, is that 10, is that the face value or is that the years to maturity? And you have to go back, scrolling up all the way up here. Maybe the function's defined up here and you have to go all the way back up to see which parameter comes first. All right, there's a way we can avoid that though. If we don't remember which parameter goes which place, we can label our parameters. We can say, all right, I don't remember what goes first, but I want to have this bond be a 5-year maturity. I want to have the face value be 250, and I want to have the yield to maturity be 0.065. Okay, so these parameters are not in the right order, but because I've named them, Python will say, okay, I'm going to set maturity equal to 5, even though that's not the first parameter. That's the second parameter. We can also use these functions on entire columns of a data frame. So for example, let's say we wanted to actually compute the price column, not just for one example bond, but the entire data frame that we've been playing with. We can do this by assigning a new column, the price column, using the ZC bond price function. But now instead of passing along individual observations, we can pass along the entire columns. Our yield to maturity will be the yield column divided by 100, so it's 0.02 instead of 2.00 for 2%. And then the maturity will just be equal to the maturity column. And we'll leave the face value as the default 1,000. We run that and we see, our prices look familiar. So next up are classes. Classes contain both data and functions, and they allow you to create many instances of them that capture different sets of data and allow you to run those same functions. And there's a million things you can do with classes, but we're going to keep things pretty simple, and I'm just going to illustrate by example the kind of stuff we're going to want to do. All right, so let's create a bank account class. And the idea here is this bank account class is going to keep track of, for each individual person, what their balance is and what their name is, and let us transfer money in and transfer money out. All right, so we're going to define a bank account class first, and the way you define this in Python is by using the word class, and then you give it a name. The convention in Python, unlike with functions and unlike with variables, is to use capital letter names for class names. No underscores, and capitalize the first letter of each word. Okay, like with functions, we create a new line below the class definition, and this will be indented. Anything indented from here on is part of the class. Anything back out to the left, shift tabbed out, is not part of the class. Okay, inside of every class we can define both variables and functions. Our variables will say, for this bank account, we'll just keep a simple variable balance, and we'll start that balance at 0. For every new account we create, you're going to have a balance of 0. Okay, how do you create a new bank account though? So this bank account class just defines what does it mean to be a bank account. When we create a bank account, we're going to use something called a constructor. So a constructor is what creates a new version of a class. In Python, the way you define a constructor is using a function, so it's def, and the notation's sort of weird, but it's double underscore init double underscore. Okay, so Python will go through and look for anything with this double underscore init double underscore name and say, I know what that is. That's my keyword for this is the constructor. Okay, functions inside of classes have this weird notation where it's self is the first parameter. What's going on in the background is that this is a function where we're always calling it in the context of a class. And so the first thing the function needs to know is, okay, which class am I a part of? Which bank account do I belong to? And that's going to be called self. Self is a reference to the specific bank account that I belong to. Okay, and let's say when we construct a new bank account, we have to give it a name, who owns this bank account. All right, and then all we're going to do with that bank account is we're just going to store the owner's name. So self.ownerName, that says within this particular bank account, so within Travis's bank account, we're going to have a variable called ownerName, and we're going to save that value based on what was passed to the constructor. You'll see in the example going forward how you would use this. Okay, so that's all we need for now. Let's run this code that will create the class definition. Now we can create instances of the class. So let's create a Travis bank account. And the way you create an instance, or you create, in this case, a bank account, is using this notation here. Travis Bank will be a reference to a new bank account object. So when I run that, what you'll see is in it requires one positional parameter. Okay, so I'm trying to construct a new bank account, but my constructor says you need to tell me the name of the owner. Okay, so let's make the name for the name here. Okay, now I've created a Travis bank account. All right, so if we want to see what Travis Bank's owner name is, I can do this. So this notation is the name of the instance. So this is Travis's bank account. And then dot says, go find me a variable inside Travis's bank account called owner name. I can also see what my balance is by doing Travis bank.balance. And of course, it's just 0. Okay, because it's going to be useful for us, let's also create a new bank account. Let's say for Serena Williams. All right, so she's got her bank account, and she's going to have initially the same 0 balance and just a different owner name. All right, so now if I do Serena, you can see her bank account is different in terms of its owner name. All right, so now if I want to start modifying the balances of these accounts, I can do it directly this way by doing, let's say, I want to give Serena some money. So I can say Serena bank.balance, and then plus equals. Plus equals says take the current value and add something else to it. Let's give her $250. Now let's look at her balance. All right, so Serena bank account has now $250 in it. Notice here that Travis bank account still has $0 in it. So when I do Serena bank.balance, I'm only changing the balance variable for Serena's bank account, not for Travis's bank account. And now so far this doesn't seem super useful. I could just have variables named Serena bank balance and Travis bank balance and keep track of them on their own. But as we start to make this a little bit richer, you'll see how this is useful. So let's do that a little bit. Let's define some functions now that are deposit and withdrawal functions. Because this is a function inside a class, the first argument needs to be self. And then I can say, what is the amount of the deposit? All right, and now I want to say that my self.balance, the personal balance of this account, should go up by the amount of the deposit. Withdrawals are going to be very similar, so we can copy that code, change it to withdraw, and now we're going to be minus equals the amount. All right, so if we run this code here, it creates 2 new bank accounts. Even though I've done that code before, my balance is 0. My Serena bank account's balance is back down to 0. Let's deposit some money in the Travis account, let's say $1,000, and see what my balance is. All right, my balance is 1,000. And now if I withdraw 50, my balance is 950. Okay, let's do another example, this time a brokerage account, similar to a bank account, but not quite the same. Like before, we're going to have variables and functions. Our variables now are going to be the amount of cash you have in the account and the number of shares of SPY you have in the account. Starting at 0 for any new account. Functions, we're going to have to do another constructor here. We'll do that the same way as before, where you need to pass in the name of the owner, and we'll store that as the class's internal owner name. All right, and you can also deposit and withdraw money from a brokerage account. So let's copy those methods down here as well. Okay, but now instead of balance, our local variable is called cash, right? Because normally in a brokerage account, you think about deposits and withdrawals going into your cash balance. Okay, so now we have deposits and withdrawals. And now let's say, because it's a brokerage account, we also want to be able to buy or sell some shares. Call that function trade SPY. It's got to be for self, as always. And then let's say we'll pass a quantity of shares that we want to buy or sell, positive for buy, negative for sell, and a price at which we bought or sold them. So what happens when you buy some shares? Well, your share balance goes up by the quantity of shares you buy, and your cash balance goes down by the total price of the purchase. So this can be our class definition. Let's run that. Now let's create Serena a brokerage account. Okay, and we can deposit some cash for her. Let's say 100,000, and let's buy her some shares of SPY. Let's say she buys 50 shares for a price of 300 each. Okay, we run that. Now let's see what her brokerage account looks like. Brokerage, let's see how much cash she has. 85,000, right? She deposited 100,000, she spent 15,000 on shares. Let's see how many shares of SPY she has. She has 50. Okay, so you can see how we can use classes to keep track of the sort of state of the world, or the state of a brokerage account, or the state of a bank account. And then we can use functions to modify that state. We can have different instances of a class where one is Travis's bank account and one is Serena's bank account, and we're able to keep track of this all dynamically. Okay, to really illustrate the power of classes, let's define a wire transfer function that lets you go between bank accounts and brokerage accounts seamlessly. And this function is going to work as long as both the sender and the receiver of the wire transfer have deposit and withdrawal functions. It's not going to need to know exactly what that class is. Is it a brokerage account or a bank account? Or does it belong to Travis? Does it belong to Serena? I don't even need to know. All I need to know is withdraw from one, deposit to the other. That's all a wire transfer is. So let's define our wire transfer where we have a sender, a recipient, and an amount. All we're going to do is withdraw the amount from the sender and deposit that same amount at the recipient. Let's now try doing a wire transfer from Serena's brokerage account to Serena's bank account. So I can just do wire transfer. Okay, and our sender is going to be Serena Brokerage. The recipient is going to be Serena Bank. And let's just wire 10,000. All right, so that runs, and now let's see what we're left with. Let's check out our Serena Brokerage. Okay, so her cash is now down to $675,000 there, but we can check the bank and see that her balance is $10,000. All right, if instead we want to do a wire transfer between two bank accounts, I can ask Serena to wire me some money, and that will work too. And then let's see where that leaves the Travis bank balance. All right, so after $500 from Serena, I'm up to $950. And Serena's bank will be down to $9,500. Okay, so you can see that this one wire transfer function lets you move money between bank accounts and brokerage accounts. Doesn't need to know anything about the details. I mean, the details here are a little bit tricky, right? On the brokerage account, it's called cash that we want to modify. The bank account, it's called balance. Some of them are one type of class, some of them are another type of class. I don't need to know any of that if I'm this wire transfer function or if I'm using the wire transfer function. All I need to know is that I want to withdraw from this, and this thing has a withdraw function, and I want to deposit here, and this thing has a deposit function. All right, and if it was a broker, it would also have those two functions, and so we can use them interchangeably. This kind of interchangeability allows you to make code that is very flexible and works in a lot of different settings. This wire transfer function can be much more flexible than anything you hard code that is specific to bank accounts or brokerages or Travis or Serena. This kind of flexibility is behind so many important concepts in programming and is going to give us so much power when it comes to testing and implementing quantitative trading strategies.